In this lesson, we discuss about strong authentication, also known as one-time password, in short, OTP. Earlier, we discussed about weak authentication, which was subject to brute forcing and dictionary attacks. And that's where strong authentication scheme comes in. When you need to protect against brute forcing or dictionary attacks, or when you need to protect against replay attacks by man in the middle, we use strong authentication schemes. Essentially, strong authentication is strong because it uses a one-time password. If we look at weak authentication scheme, you will recall that we are using the password again and again, the same password again and again. So in that case, it can be subject to brute forcing to get the password used by the user, or it can also be subject to replay attack. Replay attacks assume that if that third-party attacker, malware guy, is able to intercept the password, then he can simply replay the intercepted password to be able to log in to the server, Alice. This is because the same password is used again and again. But in a case that one-time password is used, that means if Bob, the client, has used a password to log into the server, Alice, the same password cannot be used again. So even if malware guy is able to intercept the password, he will not be able to replay it to log in to the system. And that is called strong authentication scheme. So let's look at how strong authentication works. We will discuss three types of strong authentication schemes. Lamport scheme, which is widely used in Unix network systems. Challenge response schemes, widely used in Windows servers. And lastly, timestamp scheme, which is widely used in banks by using digital tokens that you are all familiar with. Let us first discuss about Lamport scheme. Just like before, we have the registration phase and the authentication phase. In Lamport scheme, registration phase requires that the channel to exchange the password information is secured. That means that if this registration phase do not have a secure channel, Lamport scheme will become insecure. Let's look at how this registration thing works. Bob will choose a secret S. And the good thing about this Lamport scheme is that he does not need to share the secret S with Alice, the server. Instead, what he needs to do is only compute the hash 100 times of the secret S that he chooses, and only send that value, let us denote as W0, to Alice, the server. And then Alice, the server, will only store that W0 value in its database. And this value is, in fact, the hash 100 times of the secret S. Take note that Alice does not have this secret S value. Instead, she only has the hash 100 times value of S. So let us look at how does authentication works. After Bob has registered his password and credential in the Alice, the system, the server, next time he can start login by only computing the hash 99 times 100 minus 1 value of the secret S and send the resulting value denoted as W1 to the server. Once Alice, the server, receives that W1, she needs to compute the hash value, this one. She needs to compute the hash of the received value W1 and compare against W0, which is the one-time password stored in the database currently. Okay, let me repeat. Bob computes hash 99 times of secret S, send that value to Alice. Alice compute the hash of that W1 and compare against W0, which is stored in the database. If you match Alice will know that Bob is the legitimate user. He will let Bob authenticate it, and after that, she will need to replace the previous W0 values with the new one, W1, which is the hash 99 times of the secret S. If you're wondering how would the next authentication works, almost similar. The only difference is Bob will need to compute the hash 98 times and send the resulting value denoted as W2 to Alice. And again, Alice will need to compute the hash of the received value and compare against what she has in her database. And if this value match, she will know that Bob is a legitimate user. She will let Bob authenticate it. And after that, she will need to replace the old password with the new password. And this process goes on and on. The question you might have right now is how many times in this case can Alice, the server, authenticate Bob, the client, using this Lamport scheme? And what will happen after that, after those number of times has been reached? And that is a challenge for you. You need to think about it, and we can discuss this during the lecture. Thank you very much. That is about Lamport authentication scheme. In the next, we will discuss about challenge response scheme. See you next time.